Good morning. All right, today we're ready for our third lesson in Unit 1, and we're continuing with talking about rational and irrational numbers and our exploration of whether a number is rational or irrational. And today we're going to talk about why it is helpful to write numbers in different ways. So let's look at this. Today we're talking about monomials. This word is probably something that you're not very familiar with. But monomials is how you say it. And mono, the word mono means one. And the second part, meals, means term. So what a monomial means is just a single termed equation. So it's not as scary as it looks. So let's look at this. This is a breakdown of lengths, and it's talking about the unit of lengths, but really what we're trying to focus on is the powers. If we have a 1, anytime a power equals 1, any power of 0, 10 to the power of 0, 18 to the power of 0, 394 to the power of 0, all of those, if they are to the power of 0, they equal 1. So it doesn't matter what the number is, if it's to the power of 0, it equals 1. Down here we have 10 to the first power. That means that we have 110. And 110 is the same as 10 because I only have one of them. 10 squared means that I have 10 times 10, or I have two 10s multiplied together. And 10 times 10 is 100. If we look here, well, I have 10 squared, which is this one, so I have 100 here, and times 10 to the first power, which we know 10 to the first power is just 10. But what we end up with is a 10 to the third power. Here I have 2. Here I have one more, so I add those together, so it's 10 to the third power, which would be 10 times 10 times 10, or 1,000. Now let's look down here. Now I have 10 to the third power, which is 1,000, because we just solved for that. And I'm taking that times another 10, or times 110. And if I look, I have 10 to the third power, so I have 3 here, and I have 1 here. 3 plus 1 is 10 to the fourth power. So let's look at this one. Let's see if it works out. Well, I have 4 10s here. I have 1 10 here, so 4 plus 1 should give me my 5, and it does. And 10 to the fourth power is 10,000. And when I take 10,000 times a single 10, or 10 to the first power, I end up with 100,000. Hopefully you see that as I'm going down, I am just adding a 0. Okay? As I move down the chart, you're adding a 0 to each number. So now let's look at this one. I have 10 to the fifth power times 10 to the first power. So I have a 5 plus 1, which is 5 plus 1 is a 10 to the sixth power. Okay? A 10 to the fifth power, which is what I had up here, is a 100,000. And I'm taking that times one more 10, or I'm adding another 0 to 100,000, and I end up with 1 million. Okay? Now it says, look at the entries in the last column. So here, the last column, written powers. And what have you noticed? Well, what did I do with this 3 and this 1 to get 4? Well, 3 plus 1 is 4. What do I do with this 4 and this 1 to get 5? 4 plus 1 is 5. So it says, what do you observe about the exponents of the factors and the exponents of the product for each entry? Well, I added the exponents together. The exponents of the factors. Okay? So if I had one, let's say, and I'm going to write this up here, let's say I had 10 to the 9th times 10 to the 4th. Well, knowing that in order to get my answer, I have to add my exponents, so I have a 9 plus 4, so I would have 10 to the 13th. All right, let's look at this next one. Well, an easier way to do this would be to count my zeros. Tens are easy because I can count my zeros. And it says extend the pattern to write this number using powers, which means I want to start with a base of 10 because that's what my base has been all along here so far. And I want to figure out how many tens do I have to multiply together to get this number. Well, count the zeros. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So because I have 9 zeros, I have taken 10 to the 9th power, because remember, the higher I went up in my power, the more zeros I added. Okay? Let's look at the examples. Let's look up here at the product of powers rule. What this is saying is that if I have the same base, and remember the base is the big number, so if I have the same base and I'm multiplying, I just add the exponents. That can be any base. So let's say I have a w to the 4th times a w to the 8th. Well, do I have the same base? Yes, my base is w on both of these. So I have the same base, the common base of w. So my answer is going to be w to the something. In this case, I have to add the exponents because I have the same base, so my answer is 4 plus 8. So my answer is w to the 12th power, because 4 plus 8 is 12. So now let's look down here. Well, this first one, whenever there's not an exponent on a number like this 5, we should automatically know that it has an exponent of 1 because there's only one of them. So in this case, it'd be 2 plus 1, which would give you 5 to the 3rd power. Okay? Again, these are ones that I can go through and check and do, but I'm going to go ahead and start with A. Let's look at A. It says 9 to the 3rd power times 9 to the 2nd power. Is my base the same? Yes, they're both a 9, so my base doesn't change. And then I add the exponents. I have an exponent of 3 and I have an exponent of 2. 3 plus 2 is 5, so my answer is 9 to the 5th. Part B, A cubed times A squared. Do I have a common base? Yes, it's an A. And my exponents are a 3 and a 2, and I add them together, so 3 plus 2 is 5. Now, this one looks a little differently because I don't have a multiplication sign in there, but you should know that these parentheses right here mean that you're going to multiply. So if I rewrite this with a multiplication sign, it would be negative 2m times a negative 8m to the 5th. That's all that means to do. The parentheses just mean you multiply, and I can rewrite it to where it looks like the rest of them. Do I have a common base? No, I don't. So on this one, I have to do something a little bit different. I have a common base of m, so my m isn't going to change because they both have an m in them. And then I can just pull out the number and multiply them together. So I have a negative 2 times a negative 8, which gives you 16. And then my exponent on this first one, it doesn't have one, so you should automatically know that it's a 1. That's a terrible one, but that's a 1. So you have 1 plus 5, which is 16m to the 6th. If you guys have any questions, go ahead and bring them in for us tomorrow. There's also a rule like this about division. Quotient means division. So we just did product, which is multiplication, and now we're going to talk about quotient, which is division. And again, if you have a common base, for instance, there's a 3 in the numerator, and there's 3 as the big number in the denominator, so I have a common base of 3. That doesn't change. But now, whenever it was multiplication, we added. For division, we're going to do the opposite of add, so we're going to subtract the exponents. So let's say that I have a az to the 9th divided by an az to the 4th. Do I have a common base? Yes, my base is AZ. And now I'm going to subtract. I'm going to take 9 minus 4, and 9 minus 4 is 5. So if it's a division problem, you subtract the exponents. If it's a multiplication problem, you add the exponents. So now let's look down here. I have a common base of 4. I have a 4 as the big number on top and a 4 as the big number on the bottom. So my answer, the base in my answer is going to be a 4. And then you subtract the exponents. So I have an 8 minus 2. And you always take the top number minus the bottom number. So in this case, I have 4 to the 8th minus 2 power. 8 minus 2 is 6, so my answer is 4 to the 6th power. Okay? This number 6 looks more complicated than what it actually is. What they've done is that they've given you several different common bases. You have 3 different common bases in this one. You have a 2, you have a 3, you have a 5. So we can break that up. There would be a break here, and there would be a break here, which is what they've done down here. They've just separated it all out. And then you take each common base, so this first one has a common base of 2, and subtract the exponents. 5 minus 2 is 3. The second one has a common base of 3, and 5 minus 4 is 1. And this last one has a common base of 5, and 5 minus 1 is 1. Now, remember, the parentheses means I multiply, so I'm going to multiply these all together. 2 to the third power is 8. 3 to the first power, anything to the first power is that number, so 3 one time is a 3, and 5 one time is a 5. So I just have 8 times 3 times 5, or 120. So let's look at the examples. Let's do D. And D has a common base on the top and bottom. It has a common big number of 5, so I know my answer is going to be 5. And then I'm going to subtract my exponents because I am dividing. So it's 7 minus 4 because I have 7 on top and 4 on the bottom. So my answer is 7 to the third power. Okay? Now let's look at the next one, E, right here. And it has a common base of x, so the x's stay the same. My common base of x stays the same. And my exponents are 10 minus 3. And 10 minus 3 is 7. So my answer is x to the 7th. Now we're going to do one of these that's a little more complicated. Let's do H. It's one of those ones that have a bunch of numbers in it. We have to spread them out and then put them all back together. So on H, I want to keep my 5s together, I want to keep my 7s together, and I want to keep my 8s together. So this is my 3 different divisions. Okay? Common base of 5 in this first one. 6 minus 4 is 2. Common base of 7 in the second one. 4 minus 2 is 2. And a common base of 8 in the last one. And 3 minus 2 is 1. So what I end up with is 5 squared times 7 squared times 8 to the first power. 5 squared, or 5 times 5, is 25. 7 squared, or 7 times 7, is 49. And 8 to the first power, or just a single 8 by itself, is 8. So what I end up with is 25 times 49 times 8, which gives me an answer in your calculator. It's 9,800. Okay? All right, last example. This is a word problem. It's talking about Hawaii. So I need this number out of it. This is how many miles long the shoreline is. It's 2 to the 10th by 2 to the 7th. And it says about how many times longer is Hawaii shoreline than New Hampshire's. So I have to divide because I want to know how much bigger is this one than this one. So I have to divide. So I take 2 to the 10th over 2 to the 7th, which means that I'm going to subtract the exponents, and 10 minus 7 is 3. So Hawaii's shoreline is 2 to the third times longer, or 8 times longer. All right, if you guys have any questions, make sure that you write them down in the column and bring those to class tomorrow. We'll talk to you guys later. Have a great night.